Hey everybody, this is Larry. This is day 27 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. We got a hard one. Yay! 629 K inverse pairs away. So I was gonna say that I was saving this for a hard one, but I am a little bit lazy and tired today. But what I was gonna say is I got another package from Leetcode, and I'll do it unwrapping or unboxing. I'll do it tomorrow or something. But today, I a couple of y'all asked me what is my squat routine, and right now I don't really have. I mean, I have one, but it's just linear progress up. As some of you might know, I was traveling in Taiwan and Japan for like 3 months, and as a result, my gains were gone. So now I'm just kind of slowly working up my workload, like 5 pounds. 5 pounds of workout, and then kind of try to figure out where I plateau, and then I will probably just do like a 5-3-1 or something like that, both and on my bench as well. But yeah, so just a quick update for those of you who are asking me about my workout. And today I just worked out a lot, so I'm kind of spend like 4 hours in the gym. A lot of it is like warm up and cool down because I'm getting old and just kind of need the flexibility, not just the strength. And I also even did like an hour cardio. So I'm very tired is what I'm gonna say. Man, I am not. I think one thing to say is that when you get up there, my intensity is still pretty good, but the recovery is definitely not as good. So yeah. Tomorrow is a rest day though, so we'll see. Anyway, alright. Sorry for the long intro. Hopefully either you skipped it or you fast forward a little bit, or you're just hanging out. But let's take a look at today's problem. 629. K inverse pairs away. It's a hard problem. Alright, let's dig into it. For an integer array nums, an inverse pair is a pair of integers ij with I is less than j, less than n, and nums of I is greater than j. Given two integers n and k, return the number of different arrays consisting of 1 to n such that they are exactly k inverse pairs. Since the answer can be huge, return something mod, so let's do the mod song. Mod. I think the thing to the first thing to notice about these things is just look at the constraints. And here we see that n is 1,000, k is 1,000. So off my mind, I don't have an idea yet, but the idea is that n times k is okay. N times k is okay kind of sounds like a rhyme somewhere. Those are some bars. It's not a good bar, but Anyway, yeah. And then the other thing is try to figure out how to, like for dynamic programming problems, for memorization problems, the first thing that I'm going to try to do, and my hair is like really funky today. I have like a crazy hat here, but yeah, is try to figure out how to do brute force in a slightly smarter way, right? So there are k numbers, n numbers, right? So that means that there's gonna be n factorial things, permutation things. So we will see, right? And I think the idea here is that, okay, so the way that I like to think about some of these problems as well, even if I kind of have the idea, I like to play around with small numbers to kind of play around with just like the combination, right? Obviously, n factorial is going to be too slow. I don't know if I kind of went over it. But basically, okay, you start with inserting 1, and then you start inserting 2. And the 2, you have two choices. You have before 1 or after 1. And if it's before 1, then you have, k goes down by 1 or something, right? And of course, if 2 is behind, then k does not go down. And then the next one is going to be 3, right? And 3, you have 3 choices. You have either here, here, or here, right? Right? And what does that mean practically, right? Well, if 3 is here, that means that there are 2 inverse pairs. And here means that there's 1 inverse pair, or 1 added inverse pair. And here, there's no inverse pair, right? So I think from here, that's basically where I start getting a pattern. Also, full disclosure is that I kind of did this all in my head already, but I just want to demonstrate this, right? So sometimes with enough practice, and I don't know, when I was younger, probably I'm able to keep more things in my head. But nowadays, I'm just old and tired, and But yeah, before that means that you're basically the idea here, and I know that I choose 1, 2, 3, but actually, you choose 3, 2, 1, right? But here you have, for every number that you insert, you can choose either here. So this is k minus 3, this is k minus 2, k minus 1, or k minus 0, right? So that means that for every number that we insert, no matter where, we have that kind of freedom, right? So here is k minus 4, ... right? So I mean, so this complexity is not going to work, but we can at least, what I want to do is at least write it out, so we have an idea on how it would look like, right? And we'll go over it in a sec. But like, for example, we maybe just count. We have n, we have k, or yeah, or maybe like current n or something, and then k left, just to be a little bit clear. And then here, so as we said, so if current is equal to n, that means that we're already finished. So we have one possibility. Well, actually, that's not true. So if k left is equal to 0, then we have one possibility. Otherwise, we return 0, right? And then here, so let's say that, well, I mean, we can also count from 0 to n minus 1, because I don't know, I like 0 index things, even though technically, But yeah, so if it's 0, then you have 0 degree of k. You can't choose any k, right? But if the number is 1, meaning the second number, then you could choose 1 or 2. So then here we can subtract up to current to k left, right? And of course we can brute force this, or like just iterate through it by saying for I in range up to the current plus 1 to be inclusive. Yeah. Maybe we have a total count, right? And then here we add count, well, current plus 1, but k left minus I, right? And of course you may want to mod this, just to keep everything within the same domain. And in theory, this is a thing, right? Big K, I don't like small k. Oops. Right, so in theory, this is this will give you a solution, right? But let's look at the complexity. So current, is going to be 0 to n, right? K can also be, or k left is technically 0 to k, but keeping in mind that k can go up to 1,000, so it's kind of sketch. But then now each one, so what is the time complexity, right? Time complexity is equal to number of inputs times time per input, right? You could do unit analysis if you like. And here, the number of inputs is going to be O of n times k. And time per input, however, is going to be O up to k, right? Because this goes up to k left, or sorry, current, which I guess goes up to n. Okay, so maybe I'm wrong. Let's just say, it says n or k, I don't even know. I guess, actually, I think one thing that we probably could have done is if k left minus I is greater than 0, then we do this. So I guess, whatever. Right? But yeah, either way, the total time is going to be O of n times k, which is for n is equal to 1,000, k is equal to 1,000, it's going to be too slow, even if you memorize it. Obviously, we haven't even done the memorization yet, right? So then the idea is, how do we figure out how to, now we have a dynamic programming, a memorization problem that is too slow for brute force. Oh no, I'm doing the Home Alone face. But yeah, okay, so then, and it is in a way back to the drawing board, but this gives us a visualization, and at the very least, if nothing else, to be honest, it gives us a checker, right? Meaning that let's say we write another solution, that we make some optimization here. I'm relatively, this part may take practice, but for me, I'm relatively sure that this is correct. I mean, maybe there's an off by 1 somewhere, but then whatever. But for the most part, for most things, this will be correct. Just that it's too slow. So we can use this to check our other answer when we get it for smaller n's and smaller k's, so that we can verify our optimizations are correct. So how do we optimize this? Well, how do we get this to work? Really, I think that's the biggest problem, right? So then now let's go back a little bit to our fun iteration thing, right? Sorry, excuse me. Like we said, the first one we have no choice, right? So actually I just put 0 because we kind of do it from 0 to n. And then the question is, can we reduce either this iteration? So I mean, to make it n times k or n square or k square or some of these things, but basically 1,000 square, really if the approach that we're doing is correct, there are really only two things we can do. One is optimize out one of the inputs, and then the other is to optimize the loop, right? So yeah, so here we can maybe take a look and give a think, right? Yeah. And here we will say, okay, maybe we could put 0 as we said, like before we have a 1, right? And maybe we just add a few more numbers because it generalizes anyway. The permutation doesn't matter, and you just have some k value that you're playing around with. And then now let's say you put in a 4. As we said, we have 5 choices. Yeah, 5 choices to put the 4. You have 1, 2, 3, 4, 5. And then the question is, can we get rid of the for loop, right? Because I don't think we can get rid of k left, and we can't really get rid of, well, the current, the n, unless there's some like merge divide and conquer thing. So then the question is, okay, if I put the okay, so the two things we can do on the first space, right? Which means that we can put it here or not put it here. What does it mean when we put it here, right? When we put it here, put the 4 here, that means, well, now we have, what is the state? The state is just a new k, which we can do the math on, a new k, and a new n, right? Which is basically what we have here. But then what happens when we don't put it in here, right? Well, when we don't put it in here, that means that we're not putting it here. But then now another way of thinking about it is that now we have this sequence, and we're trying to put in a 4. We're trying to decide whether we put in a 4 in the beginning. And of course, like as I said, the actual numbers don't matter because the number that we're putting in is the biggest now, right? So that means that yeah, there are only 3 numbers left. Which, if you want to re-index everything, then you have 0, 1, 2, and the next number you put in is actually 3, right? And this actually works even if you have like some other funky permutations, because even in this case, like I said, the actual numbers don't matter because the number that we're putting in is the max. So therefore, even if you kind of just like put in 302, it doesn't really matter, right? Because then now you can re-index this to 1 and 2. But again, as I said, it doesn't matter because the number that we're putting in is the bigger number than all of these, right? So that means that we have 2 states that we go down to, which is that we put in the 4 here, or we don't. And when we don't, then we are 1 less number, and yeah, and then now we just have 3 numbers and 4 choices, and then we can make this recursively. So yeah, I mean, I think I get it. Maybe pause a little bit if you are having struggle, but one thing that I would change now is update some definitions, or maybe even update some variables. So current, before, I think k left is actually pretty straightforward, right? K left, number of inverse pairs left, and then current, it used to be current number to be added, right? Previously, that's now. And then now to accommodate this, what do we want to do? We actually want to say current is the number of fixed things. if that makes sense. Fixed items, right? And fixed items, like I said, these things don't, I mean, I'm putting numbers for visualization, but again, I know that I overemphasize this, but it doesn't matter because we're putting a number that is bigger than every number, so they might as well be XXXXX, right? So then here now, basically, and that's the number of fixed item, right? So then now, you can see that given that, okay, so now we say we have current number of items, so we have two choices. One is one is if k left is greater than you go to current, because current is the number of things inside, so then if you put one in the front, it's going to subtract current number of things, right, from k left. So then you can add something like count, and now once you put in the front, it is going to be current plus 1 for the next number, right? And then k left. The way that I'm doing this is a little bit awkward, to be honest. Because we're adding numbers in a weird way. Okay, yeah, I think the way that I defined this is a little bit awkward from the other way that I did it. But because the reason why I'm saying that, and let me just go through with the dot, and I think I made a mistake. I mean, it's actually not that difficult mistake to fix, but I just want to be, full disclosure, and I'm just kind of like, I didn't really think far enough on the explanation part. Like, I kind of knew how to do it, just from like recognizing it, but I messed up here. But I just want to go through why I'm like slowing down, having second thoughts. But what I was going to write is that you go to this, right? Because now the next thing is that now you have this amount, right? And then you just kind of count the number of things. And then the other thing is not ticking it, which is going to be count or current minus 1, k left, right? Oh, this is k left minus current, sorry. And then maybe like you do a mod or something like that. But it turns out that this is not right because like I said, I made a mistake. And the reason why is that let's say we don't put one here, then what happens, right? If we don't put one here, then we get to this state. But then after, let's say we put one here, then what, right? It actually doesn't go like in a asynchronic kind of way, because now then you have these items and you can kind of expand this to another thing. But then now you have to kind of keep track of how many things you want to, that you already skipped, right? And so this is kind of not, dynamic programming only works on DAGs. So this is going to have a nasty cycle, and it's just going to give you the wrong answer, right? Maybe you even run it and it'll just tell you that you're wrong, or maybe just infinite loop, really. I think it just, yeah. Right? So then now how do we fix it? So, I mean, the fix is easy only because this is just like very wrong, right? So the way that I would think about fixing it, and I think I just did the other solution in a tricky way. But the way that I would fix it is that, okay, now that we have a sort of a recursion. This isn't quite right, or recurrence. This isn't quite right for things that we see, and kind of a really short explanation as to why it didn't work. But then now we can think about it maybe just going in reverse, right? And going in reverse, then now it's still fine. But then now we're saying, okay, let's say there are current number of items and there's k left, and then now you have to say, okay, given the biggest number, and the biggest number, where's the biggest number, right? And the biggest number is either the first object, So let's say now you have 4 things. So then now you have to define where the biggest number is. And the biggest number is either the first object. If it's the first object, then you have -3. And then otherwise, then it is and then now if it's the second object, then you have something like I guess it's just x's now, right? Right. If it's the and then now it goes down to whether it is the second object, right? With the thing eliminated. Yeah. Is this right? Man, maybe I'm just like leading y'all to wrong paths. But I would say even if we're really wrong here, these are kind of ideas and things that kind of come up in other similar problems. So it is definitely worth kind of exploring it kind of in this way. But how do I do it backwards? So yeah, if this is equal to 0, then with 0 items left, then yeah. All right. So we change base case, and then now if it's the first item, then we try to find it on a smaller case, and this thing is fine. Otherwise, we want to count, but this isn't enough because this assumes that the next number cannot be It assumes that the next number cannot be, let's say we pick this one, but there's actually 3 numbers left, not 2. Huh. Yeah, I think I'm wrong on this one. Wow. Sorry, friends, for kind of leading y'all through the wrong path. How do I fix it? What is K left? At least it terminates. Okay, just want to make sure that I didn't make a mistake on that one. But let me think about this. And I thought I had that idea, but apparently I'm just like, well, very wrong. I mean, the way that you would fix this is by adding another dimension, but obviously we don't want that because that would just be too slow anyway. So that's why like I'm kind of trying to think through it a little bit. I guess it is a hard one. I haven't done it in a while. Can I express this with the same current? No, because if I do this, that's just silly. Oh, okay. I guess we could do it that way. Can we? I think the way that I'm thinking about it is a little bit awkward, but yeah, okay, maybe that works. I mean, I could maybe do this, but I don't think that works because we have to figure out a way to terminate it. Oh, I see. That is a ridiculous problem, though, if that's true. I think I got it, but that is so hard. Like to explain, or not even to explain, but just to like come up with. Wow. I mean, okay. I mean, I'll try. I mean, I think I get it, but it's just wow. Definitely not my first, because to be honest, it's just harder than I expected. That's all. Okay, so what are we doing here, right? This is not the right answer yet. This is kind of similar to what we were doing, but this is but it also in a way not really, right? But basically, this is the idea of, okay, let's say we have current number of fixed items left, and then now it is so now before we've been counting from the front to the back. So the idea is just to count from the back to the front, right? So let's just say here we go. Okay, so let's just say is, if it's this one, then we can, if it's bigger than this one, well, if the smallest number is here, then we're done. But then the question is that on a K, whether you want to do a little bit more. So then here, now we can actually cut it. Oh my, this is not an easy problem to explain. I mean, I get the math and that's why, but like I'm trying to explain it more visually. So my apologies. This is kind of very hard, especially if you haven't done it before. Because in my head, just to kind of give you a little bit of an insight to my thought process, is that I was just thinking about like the different permutations, and some of it is like kind of brute forcing all the algorithms in my head, not the algorithm brute force, but brute forcing on the algorithms in trying to like, well, to be honest, if like we said, if we wanted to if we want the complexity to remain n times k, there really only a limited number of ways to do it. And then here, idea is that, okay, we're done with the current number, right? And then here is, let's move one space to the left, right? So this is basically brute forcing the summation. And this part is actually, I mean, I don't know if I have a good visualization for it, but if you kind of recall what we had, or maybe we can kind of rewrite this a little bit similar to what we had before with the for loop. I maybe should have kept it, but whatever. But basically the idea, and you might know, and this idea is, I think, easier to understand-ish, right? Which is that for I is in range k left plus 1, and also current or something like this, right? So min of this and maybe current plus 1. I don't know if it's current plus 1 or current. Doesn't matter, right? For point of visualization. But k left is greater than current. Then we have, oh sorry, if k left is greater than I, right? So this is basically what we had before, right? And the idea here is that this is not an easy thing. so definitely, if you didn't get it, I don't know. I mean, it's taking me a while, to be honest, right? So like I wouldn't feel, wow, 28 minutes. But yeah, but basically the idea is what I would call loop caching. But basically this idea is, if you kind of expand this out, this is just going to be, total is equal to, or this loop, which you can rewrite as count is equal to this. Can it be 0? I guess it could be 0 actually, right? Well, I mean, okay. Actually, in this case, it's current minus 1. That's why I got a little confused, because now you're done with the current number, right? And it'll be this plus something like that, right? So it's a little bit yucky, right? So yeah. So it looks something like this is what this loop does. And then the idea here is almost like a prefix sum, if you're familiar with that, is that now instead of, we have this recursion, or this function that we're trying to get, we can actually, we should actually get some, and that's the thing where if we had current, well, actually technically with minus 0, it actually goes to current minus 1, and then the next one would be current k minus 1, and because of this actually, so it is this thing, right, is what we're proposing. And basically this thing expands out to to this plus count of current k left minus 2, right? Dot dot dot. Right, and so you could kind of see, and this, like I said, it takes a bit of experience to kind of figure it out, or even just like, you know, oh, how did I have it? Right. Yeah. Right, all the way up to count. Well, actually, I guess this actually terminates. What I mean is that this now kind of expands it out, right? I'll expand it one more time just for clarity. But yeah, but this expands out to -1, this thing plus count of current k left minus 3, right? And you can kind of expand this all the way out, and it'll be basically this thing, right? Kind of. Why did I say kind of? Because and this thing is actually a little bit wrong, because this should be maybe k left minus current or whatever, right? Like this is the actual min, but it could be 0, but let's actually change it to this for now, right? And here, but in this case, we kind of expand it out, and maybe you do a, like I said, like if k left is equal to 0, just make sure that k left is greater than 0, otherwise. Yeah, so let's say you have something like this, and you should anyway, otherwise you have negative k left, which is meaningless, or it's a easy optimization in either case. But yeah, if you kind of expand this out even to this will actually go to this would actually go to 0, right, until it is done, because we don't keep track of the current. So that is kind of ridiculous, right? So then now we basically went from this function, which is our for loop that we had, and we kind of understand. Why did I remove it? It's fine. I trust you. You can go back and look at the for loop again. But yeah, I don't have it in a good visual way like I had with the x's. Apologies. But yeah, but that's basically the idea. And then now, but now you have this versus this, right? So this isn't it. This isn't the answer yet, because now we have this thing, or like our current thing is this, but we want this. So then what happens? Well, the idea I kind of hint at is, and this is actually 0. Well, this can. The idea that I was saying is going to be prefix sum, right? So yeah, so let's actually expand this out a little bit. You have k left minus current plus dot dot dot, right? Let's dot 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 this part and dot 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 this part, right? Yeah, so then you have like these two things. So then now what? Let's actually expand this one more out, right? Well, yeah. The short answer is that now I hope I'm right. I mean, I think I'm right, but I should have tested this before. But yeah, but basically here now, like I said, you have this, so, and you have this, so then now you just have to subtract out this thing. So then yeah, and I think you can write something like but I don't know that this is quite precise, right? Or is it? And well, here we actually don't want this, because this is actually wrong, because this is just this part, and we have to add the dot 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 part. But this part actually is equal to count of current k left minus current, I think, or maybe -1, right? Yeah. And this part is equal to this part, so yeah, so this would be this. And you, obviously, if you don't do it that way, then you have to write out this for loop, and this for loop is also going to be like, you know, add a lot of time complexity. So that's what this part is. I'm trying to think whether that makes sense, or that's precise enough. because then here, this also, because this also does recursive, right? As in that this also subtracts on k left minus 1. I think this is right, but this stuff is kind of tricky. But that's basically the idea behind the prefix sum, is that the way that we did it, we have this, and then now we have this. And it's definitely not an easy thing to come up with. Let me just leave it here then. Let me run it real quick. Alright, well, that didn't go well. Do I have the right base case? I think this part may be a little bit awkward. Let's just actually do something like... I guess I like it here a little bit. Is this right? Yeah, okay. I think I like the equal sign, but I think the part that I'm struggling is trying to figure out if we need the entire stuff, or it's either that or this. Maybe that's a little bit better, but well, we're getting zeros, so maybe there is some like a base case issue instead. Oh yeah. Well, we're getting zeros because we're counting down instead of up, so this thing is wrong. That's actually a little bit of silliness. Okay, so we have 2 instead of 2. Am I off by 1 somewhere? 3 0 is 1 1. Okay. Maybe am I off by 1? I mean, I'm literally off by 1, but I mean like on the indexing. So 3 1. I mean, I guess we can just print current k left and then total, right? Just debug it. K left being 0 is a little bit sad, or less than 0. How are we doing that? I thought we double checked. How are we getting negative k left? Definitely should fix that. Oh, this is man, double negative stuff hurts. All right. I mean, yeah, it's still wrong, but at least we fixed that part. Okay, so 3 1. Three 1 goes to 2 1. Three 1 doesn't it go to 3 0 as well? Okay, yeah. So it's this plus this. 3 0 is 1 is correct. 2 1, 2 numbers, 1 inversion. There's 2 ways of doing it. Seems wrong. That's the thing, is that I don't know if I'm over subtracting it, but that would only give the other side. But man, this is a hard one. I mean, I think the idea is right, but I think maybe I'm just off by 1 somewhere, which we should still resolve. But okay, so 2 numbers. Yeah, okay. 1 number. Oh, am I off by 1? I think yeah, okay. I changed it to 0 indexed, and I think that's why. Okay, fine. Yeah, okay. That's just a silly thing, because I changed to 0 indexed, and so it was doing 1 extra number. Yeah, okay. Let's play with something slightly bigger. Oh no. Okay, I mean that's good in that, you know. Well, let's find a smaller case to be wrong. So then we could debug it easier. Huh. Oh, did I change something? No. Because I think this one I'm not sure, because there are 2 ways you can write that formula. That's why I'm a little bit sketched. Okay, so it is this way. That is hard. Okay. Yeah, I mean, so the reason why I wasn't sure about this, to be honest, is that even though this is equal to, like I said, this is actually, this thing that I'm highlighting is actually equal to count of current k left minus current minus 1. There's no easy way to only do this deletion once for the row, right? Because this thing expands out to all this stuff, but we also keeping in mind that in the future, if we call this, if we call, but basically the idea is that if we call this, then we also call this, then we basically double deleting a lot of these counts, and they kind of cancel out in some weird funky way. But if we do current minus 1, then now another way of thinking about it is that this number will subtract this number, and then this matches up with, well, this minus 1. So this matches up with this, and then all the way to k minus current, and by definition, this will subtract and current minus 1, so it would only so this would subtract k left, so you should have the right number. But well, this only goes all the way down to 0 is what I mean, right? I don't know. This feels very sketch, to be honest. I mean, I think this is roughly right, but it still feels sketch. All right. Well, let's just say for now, that's basically the idea. We have to add memorization. I'm not gonna. Okay, fine. Let's just actually do it. I'm just doing my usual memorization thing. I'm not going to explain it too much today. We kind of went over it all week, and I'm a little bit, you know. And to be honest, it's not just because I'm lazy, though. It's just a little bit on it. It's just I'm not. I'm just like eager to test to make sure that this is right before I kind of want to go further, because I'm kind of not feeling that super confident about this. Because it's just a lot of, I mean, the core idea is right, just to be clear. I believe in the idea, but it's just so easy for, like, I'm having trouble doing all these prefix sum formula and recursion and stuff like this in my head, yeah, it's just tricky. Right. Yeah, it's much faster, and then now we can try something bigger, like 1,000, or oops, 500, 1,000, right? I mean, the complexity I'm not really worried about anymore, because this is just going to be, I'm just looking at the right answer. I guess if it is the right for these, it's going to be right, but this is a ridiculous problem, to be honest. How did I do it last time? Did I explain it? Man, I mean, this is the same code as I have today, pretty much, but I wonder if I did it quicker though. I mean, this is the same idea, prefix sum, and then just like pre-calculating it, but this is bottoms up. But yeah, hopefully this idea kind of makes sense. Bring it back here. Let me delete this so you can see all the code at the same time. The code isn't super interesting. I think the idea is actually pretty cool. The idea of prefix sum and having to remove it, but it's very hard. Like I said, I don't know. It's not an easy one to do for sure. I think for me, I would consider it too hard for an interview. Apparently it has, but I don't know. Is there a user solution? take a look. Brute force. Okay, that's just silly. You're wasting my time. DP. Oh, I mean, this is also too slow. DP with cumulative sum, which is, I guess, kind of what we're doing. What is going on? I guess this is what we're doing, but this is a 1D. Oh yeah, I mean, I guess if you convert this to bottoms up, of course, it's gonna be 1D. The way that it phrases is a little bit weird, but yeah, I mean, I don't know. I don't know what to tell you. I mean, you saw it live. I know that I do spend some time trying my best to explain this problem, but you know, so maybe I get it in like if I have to estimate, and I kind of went the wrong path a little bit, though I knew how to do it, but like if I have to estimate, like it would probably take me about 20 minutes to solve this problem, which is, to be frank, like, and you know, maybe you could call it arrogant or bragging or whatever. Like, I think that's relatively pretty good. So I think that's just too hard for interviews, just because, like, you know, like if you haven't seen it or done it specifically, and you're kind of doing it from scratch. And today, I don't know, like I did it today a little bit from scratch. Like, I don't remember the previous time I solved it. I do remember the ideas from either this problem or other problems, similar problems. I have those things. But it's still not an easy problem. This is a really tricky technique to kind of recognize. So, I don't know. Let me know in the comments what you think. This is a very long video. Hopefully you enjoyed it. So no extra premium problem today. But yeah, let me know what you think. Stay good. Stay healthy to good mental health. I'll see y'all later and take care. Bye-bye. Have a great weekend, everybody. Bye-bye.